Hi guys, I am Ankit. In this video, we shall see another problem on LeetCode. Pascal's triangle part 2. So given an integer row index, return the row indexed row of the Pascal's triangle. So in the Pascal's triangle, each number is the sum of two numbers directly above it. So they have given zero indexed row here, and we have to write the return the if we given an integer nth row we have to return in the Pascal's triangle. I hope you guys how do we know how to perform the Pascal's triangle. So we start with the zeroth index. So to compute the first index 1 1. Here you don't have any previous element, here don't have a previous element, so you take 1 1, inherit that. Next for the second row, I mean zeroth row, first row, second row. For second row, as we know, how do we compute 1? No other element, so 1 you inherit. And for 2 it's both previous element you take it, and you can see the last element will remain, the ending elements will remain the one in each row. So next when you come to the third row, for computing 3 1 plus 2, again for this 3 1 plus 2. So next coming to the first, second, third, fourth row. So 0 1 2 3 fourth row, how do you compute this element? The previous two elements 3 plus 1 of the above row. And here how do we get 6? So we get 6 by 3 plus 3. That is how we get the 6. Here also how 3 plus 1 will be 4. So how do we compute it here is, so 1 plus 1 this will be 2. These two will combine together will give you 3. Again 2 plus 1 3. 3 plus 1 4. 3 plus 3 6. 3 plus 1 4. So this is 0 0 1 2 3 4. And why am I taking 0 row? Because they have said that it's a zero indexed row. So that's the reason. So now our task is they're given some n, okay, row index, and we have to return the that row values of that Pascal's triangle. So how do we do that? So if you actually observe this, what is happening over here is we start with 1, next you compute again 1 1, next 1 to 1, how do you get it? Extra one element you add, third element. To compute the middle element, the previous row take that particular index and previous index, so 1 plus 1 will be 2. Then coming to the third row, how 1, again 1 more here. So compute, how do we compute these two elements? So for this element, previous row, the element at this position at the previous position, so 2 plus 1 will be 3, and here again 2 plus 1 will be 3. Again for the last row, how do we compute? So have one more 1, and then so its length will be 5. So how do you get this element? 3 plus 1 4. For this element, uh, that position and a previous position of the previous row, this row. So 3 plus 3 will be 6, again 3 plus 1 will be 4. So this is how we compute the Pascal's triangle value. So if they say n equal to 4, then you have to return this particular row. If they say n equal to 2 3, then this row. N equal to 2 means this, n equal to 1 means this, n equal to 0 means this. So this is what they have asked in the question. So how do we perform the operation actually? So one thing we got to know is if they ask n equal to 4, the length of that row will be n plus 1, right? So 0, 1, 2, 3, 4 index. So 5 elements are present in nth row. Nth row means fourth row. So if they given n equal to 4, we will create an array of size 1, 2, 3, 4, 5. Okay, let's say. And initially, let's initialize all the elements with 1. 1, 1, 1, 1. So if they give an n equal to 4, let's say, so we create an array of size 5 and all the elements initialized to 1. So once we are done with this, do we need to calculate this array, what if they say n equal to 0, do we need to calculate anything? No. Just return an array with element 1 of length 1 with element 1. If they say n equal to 1 also, we will return an array of size 2 with elements equal to 1. Directly we can return it. What if they say n equal to 2? Then we need to compute this middle element, right? Because first and last element remains the same. If n equal to 2 means the length of the array will be 3 in this case. So for if they say length n equal to 0 means first one length. If n equal to 1 means array of length 2, then this length, this length. Okay. So if n equal to 3 means this entire length till here. So this is array length of 3. Not n equal to 3. If n equal to 2 means we will return the array of length 3, where first and last element in the array will be 1 itself. How do we compute the middle element? Middle element is, how do we compute is, the previous row which take 1 for that position element and the previous element. We add this to 1 plus 1. But the 1 plus 1 actually in this array, if you see, this is nothing but this element and this element, right? So if you want to compute element this position, we add the element at this position and the previous position. How much it is? 1 plus 1 will be computed. Got it? So basically we are doing 1 plus 1, but 1 plus 1 is nothing but if we take consider an array length of 2, that will be this only here. So in this only 1 plus 1, that is 2, what we need to compute. Okay, so that's it. Now what we'll do is, so now you could see if we have an array length of 3, yes, we have computed 1 to 1 as per the condition. If we want to compute array length of 4, that means n equal to 3. How do we compute this? So computing this, we need to have a length of 4, array length of 4, if n equal to 3. So array length of 4. The first and last element in the array will remain 1 itself. How do we compute the middle two elements? So how do we get 3? 3 is from 1 and 2 here. So 1 plus 2. So actually, if you want to compute the element in this position, 0, 1, 2, 2th index, 0, 1, 2, 2th index. So I'll write 0, 1, 2, 3, 4. So 2th index if you want to calculate, 2th index plus 1th index, first index. You add the element. So 2 plus 1 will be how much? It will be 3. Next again for this element, first index, how do you calculate? This 2 plus this 1. There is an element this 2 and this 1. How much it is? 3. So within the array you are calculating the elements. Imagine that the size of the array is temporarily 4 now. So now we have got 1, 3, 3, 1. Yes, we have got this thing. So let's say n equal to 4 we have to calculate now. How do we calculate n equal to 4? In that case, n plus 1 will be the length of the array. So just increment the length of the array. So this entire array will be the length now. So how the first and last element will remain the same. How do you compute this element now? 4, 1 plus 3. So 1 plus 3. This element and the previous element, how much it is? 4. Next, how do you compute this 6? 3 plus 3. So if you want to update the element at this position, this particular element and the previous element, 3 plus 3 will be 6. But one more thing which we need to notice here is, okay, now this is done. How do you compute this element position? Again 3 plus 1. The element at this position and previous position, that will be 3 plus 1 will be 4. Okay, so we have got 1, 4, 6, 4, 1. But one more thing which we notice here is, I'll just do everything reverse. Okay, so initially we have this 1, 3, 3, 1, 1. So what we start from here? We start from here for computing this element, this position element. 3 plus 1, how much it is? 4. For computing this element, 3 plus 1, 4. We have got, yes. For computing this element, 3 plus 3 should be 4. But we have lost track of it. We have 4 here. 4 plus 3 will be 7 here, which is not correct. So that is the reason why we start computing from the end. This element, 4. It will not affect the next element. So computing 6 means this element. It will not affect the any other element in the array because you are taking element at that position and the previous position. So again I'll erase all. Yeah. So that's why what we do is 1 plus 3. How much it is? 4. So this is done. It will not affect any further elements before to this. Now when you come to this position, this 3 plus previous to this. How much it is? 6. Again for this position, this 3 plus previous to this. 1 plus 3, 4. So this is what we do. If you update here, then it will affect the next positions in the array. So this is how we calculate the Pascal's triangle nth row value. So basically we have this. So as you know, we keep on updating the values by adding the elements in the previous row, that position and the previous position. But how do we represent this? 1, 1, 1, then 3, 4, 5. If n equal to 1 they are given, then the length of the resultant array will be n equal to 2. So that will be the length of the resultant array. So what should we do? So n equal to means I am telling the resultant array. Okay. So if n equal to 4 they are given, first we start computing with n equal to 1, n equal to 1, n equal to 2, n equal to 3, n equal to 4. Apparently n equal to 0 and n equal to 1 are not required to compute because they are already 1. We initialize the array with 1. From 2 to 3, 2 then onwards, any row if they ask, we need to compute the values. So how do we logically implement the answer here? So as I said, first what we need to do, if n equal to something they are given, n plus 1 will be the length of the array. So let's say 5 is the length of the array because n equal to 4 we have considered. Next what we do, we initialize all the elements with 1. Okay, once you initialize all the elements with 1, how many loops we need to run? So if they say n equal to 4, we have to run from 2, 3, 4. So I equal to 1 till I less than 4. Those are the number of loops which we need to run, right? So what we do is, the outer loop will be nothing but for I equal to 1, I less than the n value, whatever row index they given, I plus plus. Do we need to give I less than or equal to n? If they give n equal to 4, 1 comma 2 comma 3 comma 4, 4 iterations is it required? No. As I said, these 2 iterations you can skip. From here we do. So whatever n they give, n minus 1 iterations we need. So n minus 1 means I equal to 1 till I lesser than n, I plus plus. These are the number of iterations. So this represent I equal to 1, I equal to 1. Okay. So this is I equal to 1, I equal to 2, I equal to 3. So when we are at I equal to 1, this is I equal to 1, right? When we are at I equal to 1, now we will look into each row. When we are at I equal to 1, we are computing only one value. When we are at I equal to 2, we need to compute two values, this 3 and this 3. When we have I equal to 3, we need to compute three values. So the inner loop will be for computing the values at each row for j equal to I, j greater than 0, j minus minus. Why? If I equal to 1, only one loop we have to run, right? So j greater than 0 should be given. J equal to 0 means 1 comma 0, two loops will be run. So only one loop we have to run. So j equal to I, j greater than 0, j minus minus. How do you add the elements? So as you know, if we create an array, let's say row of I will be plus equals to row of I minus 1, not I, j here, inner loop. So this element will be equal to this element plus this element. This element will be this element plus this element. This element equal to this element plus previous element. So that's why we create. So if you, let's say if you run for n equal to 2 here. So if n equal to 2, you initialize array of elements 3, 1, 1, 1. Then I equal to 1 you run. So I equal to 1. I lesser than n means I lesser than 2, I plus plus. So initially I will be equal to 1. So j will be run from j equal to 1, j greater than 0, j minus minus. So j equal to 1. So row of j will be equal to plus equals to row of j minus 1. So that is means row of j plus row of j minus 1. So row of j means nothing but j equal to 1 here. So this is index. This element will be equal to this element plus this element. So that will be updated to 2. That's it. Then j equal to 0 will run here because j minus minus means j equal to 0, which is not greater than 0. Done. So you come out of the loop. Then I equal to 2. Is it possible? No. I lesser than 2 are given. So that's it. You return the answer. So this is how we calculate. But one again question, why did I give the loop in the uh, negative direction ending from the array? Because this is, as I said, if you keep first update this 1 plus 3 equal to 4, then when you come here 4 plus 3 will be equal to 7 here. So that's why that will be a problem, right? So if we have 3 here, 3 here, so if you do 1 plus 3, 4, 4 plus 3 will be 7. So that will be a problem. That's why what we do is, if you have 3 plus 3, so 1 plus 3 will be 4. This will not affect anything. 3 plus 3 will be 6. 3 plus 1 will be 4. So we run the loop from ending to the beginning of the array. So this is the logic. So we will implement this. At first we will have an array. Let's name it as row of size what? Row index plus 1 and initialize everything to 1. Fine. So later what we need to do? Once you initialize the array, so we have initialized the array and every defined the array and declared the array and initialized it with 1. So next we run the loop. So for I equal to 1, I lesser than row index I plus plus. Inner loop will be j will be equal to I, j greater than 0, and j should be decrement. So simple, row of j plus equals to row of j minus 1. Basically row of j equal to row of j plus row of j minus 1. So at the end we return the row. That's it. So we will run this and check. Yeah. And for Java I'll explain the logic also. Same thing, we initialize the list, array list, because the given return type as list integer here. So you run over the row index, iterate, add 1 to it initially. That means we can't initialize as we do in the C++, right? Like this. We can't do it. So that's why you add 1. So later j equal to 1, j greater than 0, j minus minus. You set the each index value in the list with row of the element at j position, j minus 1 position. You assign it at j position. Then you return the list integer at the end. So we shall submit this also. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with other video in the next session. Until then, keep learning. Thank you.